Hello and welcome to another episode of Dominic Does DIY. We will be continuing the Bluetooth Relay Remote series, this time examining the central side of the system. For this one, I use a Hi-Let-Go ESP32 with 2 buttons and a small LCD display. We will go through the central side Bluetooth firmware and how to use it to be able to communicate to the main board from the remote. Later, we will go into the details of the TFT display and understand what it is and what it is doing. Then we will cheat and just use the Arduino TFT ESP files someone else wrote. But without further ado, let's begin to look at the Bluetooth aspect of this device. So what we will need at this stage is the following. We'll need, of course, the ESP32 LCD screen dev kit with 2 push buttons. I've got what it looks like there on the Amazon site. And we will need the VS Studio plus Platform I/O. This is preferred over Arduino IDE for me on this ESP32 when I was working. It's just a better programming environment in my opinion. So if you haven't downloaded Visual Studio, I'd go ahead and download that and download the Platform I/O. So first things first, let's go ahead and take a look at the firmware and our header files. So we need to include Arduino.h. Like I said, because I am using the display, I'm not going to go into it now, but I have the TFT ESP header file. I've also got the required ones for this, which is the BLE device.h, the BLE utilities.h, and the BLE advertised device.h. So we need these header files in order to make the system work as a bare minimum. Now with Platform I/O, there is also something inside Platform I/O called the Platform IO.ini file. This Platform IO.ini file, we have to modify it a little bit. For me to get the TFT ESP to work, I had to add this line under the library dependencies. And I had to also, in order to use the terminal built into the VS Studio and Platform I/O, you also have to tell it the monitor speed that we want to work with. So of course my code I output to the terminal for serial prints at 115200. So I just got to tell Platform I/O that my monitor speed on this is 115200. Otherwise it will default to 9600 baud. So this is the one caveat with using Platform I/O as opposed to just the Arduino IDE is there are a lot of things that you have to set up in this INI file. The way that Bluetooth operates is it works off of UUIDs. So all services, all characteristics have to have a UUID. There's 2 formats for this. There's the 16-bit UUID or the 128-bit. We will be using the 16-bit for simplicity. In addition to that, there are always 2 sides of Bluetooth. It's the peripheral and central side, and depending on your sources, it may be referred to as the server and client side. So the peripheral is the server and the central is the client. We set up the peripheral already with the Arduino and the relay board with Bluefruit as the BLE function. And now we're going to establish the central, which is going to use the services and characteristics that are being broadcast by the Arduino board. So in order to make a connection and be able to communicate, we need to have a few things from the peripheral side. One, we need to know the advertising name. What's the name being advertised? We need to know the service UUID. We need to know the characteristic UUID so that we can write to something with the central. And we need to know the characteristic UUID peripheral is going to use to notify us of a change. So those are the 3 UUIDs that we need to know. It's the service, it's the write characteristic, and it is the notify characteristic. We need these UUIDs. Now, in order for this program to use this, we need to have a few pointers. Right? We need a scan object. We need a pointer to the object of our connection, the BLE advertised device. And we need pointers to each of the characteristics so that we can write to them or use them as needed. So now that we got the basic information of the peripheral and understand it for the central, let's look at the basic initialization for the Bluetooth scanning. So remember our peripheral, it is an advertiser. So that means that our central, it has to do the scanning. It has to scan for that advertisement. Let's zoom in to the actual initialization of the scanner. So all these intervals are kind of standard issue things. The interval is how often do you want to scan, and the window is how long are you going to be scanning for. And then, of course, you start the scan. But of all these things, we have to really pay attention to is the callback. So the callback here is the meat and potatoes of this entire process. As a central, you're going to be looking at everything. It's indiscriminatory about what advertisements it sees. It will actually see every advertisement out there. And if you open up any type of Bluetooth sniffer, you will see there are 10s, 20, 30, there are many different Bluetooth devices out there. And this device is going to actually look at every single one of those and process it through that callback. And it is just going to round robin in it. It's going to look at one, pass it on, go to the next one, and it'll just cycle through this infinitely until you tell the scan to stop or it finds what it is looking for. So it is inside this callback that we are actually going to put in the details of what we are looking for to make a connection and stop the scan. Going to the device callbacks, I created a very simple, not very secure, but very simple way in order to connect to what I'm looking for. Right? One, I'm looking for, does it have manufacturing data? So I did set that up. I kind of blew through it in the prior video, but I did create some manufacturing data that I applied to the advertisement. And so the second thing that I'm looking for is the name, right? And this is why we need to know the advertising name, because I'm using that as the parameter by which to connect to this device. So my two connection points is going to be, does it have manufacturing data? And does it have the name Adafruit Bluefruit LE? If these two things are true, then this is where I go ahead and stop the scanner because I don't need to scan anymore. I found what I was looking for. And I go ahead and register this device as an advertised device. So now I got what it is that I want to look at of all these advertisements out there. I've now got the one that I want to connect to, right? And so I haven't actually connected though. I've only found the advertisement. So I haven't actually gone to that next step yet. Right? And what do I got to do is I got to create a flag. The way that the firmware works is I cannot connect directly to the advertisement inside the callback function. I got to exit the callback function and get into the main program again. And once I'm in the main program, then I can connect to this. But I'm just right now memorizing what advertising data I do want to connect to out of all the advertising data out there. Also, you're not limited to just these items. Actually, you can filter by whatever means you want to filter on. If you look up BLE advertised device.h, you can see other information that can be transmitted in the advertising packet. You just got to ensure that your peripheral is broadcasting that data, and then you can filter on that one also. So now that we have found our advertisement, we set the connect flag. We'll go back into the main loop of the program, and then we'll actually call the connect to server function. So the connect to server function is where all the information is really transferred. So we're going to check our services available. We're going to start looking for the characteristics, and we're going to register any notification characteristics. So we can see over here with the connect to server, the first thing we do is we establish a connection. After we establish the connection, first thing we're going to do is look for the service UUID. So long as it has the service UUID that we're looking for, then we'll go ahead and connect. If not, disconnect and return false, right? Like get out. So the next thing we got to do is look for our characteristics. Is our write characteristic available? Is our notify characteristic available? So long as those two are available, then we're good to go. If not, we will go ahead and disconnect and get out of this function because this isn't the one we were looking for, or it doesn't have enough information for us, right? We don't see the characteristic that we need. So long as we find all of our characteristics, then we can go ahead and check. Hey, is this a read characteristic? Okay, give me the value. Give me my first value from it since it's a read. And is this a notify? Can we receive notifications from these characteristics? If so, then we have to register for notifications. And all we do here is then we put in the function call, the callback, that we want to register for this notify. So anytime the peripheral changes a value and notifies us that something has changed, this is the function that we want to call when that happens to handle that information, that new information that has been changed. So we can now look at the notify callback. What function are we going to call when the peripheral tells us the new relay information? So we can see here the inputs to this function call is the characteristic information, the p data, the length, and the isNotify boolean, right? So in this, what we're really going to care about is that data. So when we registered the characteristic on the peripheral side, actually what we did was we set how many bytes this characteristic has. When we originally set this characteristic up, we set the characteristic up to only have 1 byte of data. But if we wanted to change that characteristic and make it have 8 bytes of data, then p data would be the array of bytes of data being transferred between the peripheral and the central upon this notification. But since on this one we just have 1 byte of data, we can use that 1 byte, that p data 0, and we can use that to then change the display and update the relay image that I have going on the LCD display to give some user feedback to show that, hey, look, it did change, or this is the new status of the relays. As for the write characteristic, it is pretty simple. Anytime we have a button press, then we go ahead and we write a value to that characteristic, and the peripheral then can go in a loop and look for that characteristic and see if anything has changed. So long as the values are the same on it, then there are no issues and he doesn't have to do anything. But if he goes in there and he sees a change, then he can react on that updated data. So now we have our entire setup. We have our relay board down here with the LEDs to react whenever the relays actually engage and disengage. And we have our highlight go 2-button dev kit right here with the program we just wrote. So now when I push a button, it's going to send over Bluetooth to the relay board and be able to turn the relay on and off with the remote. There's one. There's the other one. And we can see that every time I push a button, the relay works over on that. So we have a functioning Bluetooth remote. There are small delays that you can see when I push from the time I push the button to when the thing triggers sometimes. There's a slight delay. That is because of the communication between the Arduino and the Bluefruit right here. So because that COM that we have to do and the UART communication, it is really slow between the two. To show the time it takes just for the Arduino to communicate back to that Bluefruit board over that 9600 baud to see how much it slows it down, all I'm going to do is inside my loop is I'm going to just print out a dot every time it goes through this loop. And I'm going to count to 10. At the end of 10, I'm going to print a new line. And I'm doing this. I'm going to do this because of the mere fact of this is going to loop through so fast. If I just do dots, you're not going to really see anything on the serial output. So I'm hoping with printing out this new line, when the serial monitor starts spamming, we'll be able to see the NL moving up on the serial serial monitor in order to see that stuff is being written at a really rapid rate. Whereas if I just make them all dots, we wouldn't be able to really see any kind of activity. I am commenting out the one communication to the Bluefruit from the Arduino. So with this commented out, this is just literally going to loop upon itself to see how fast this thing can go through this loop cycle. So let me go ahead and program this. So we can see here my system startup, all the stuff, it's setting it up, we're getting the characteristics, the services, we're setting everything up, and then boom. And of course it's happening so fast that it's just spamming and even the new lines aren't helping at all. So I'm hoping that you can see this twitching zeros at the bottom of the screen that's happening. So now what we're going to do is we're just going to uncomment this. And then we're going to re-upload. Again, system start, factory reset, go through the process, advertise, set up all the stuff, advertise. The other one is going to be connecting soon. And now we're ready to go. But you see here, the dots that are going across, before it was spamming that information. As soon as we added just one single line, as soon as I added this one line right here, then all of a sudden, my speed just to run that command drops immensely. And so this is that delay that you see when you press the button and you transfer it over. And this is just simply to do with the fact that it is a Bluefruit and you're running over that 9600 baud. But if we were actually running a Bluetooth to Bluetooth and we could communicate directly, this would be a lot faster because you would get on-change interrupts and things like that on the NRF module that is not available on this particular Bluefruit. So if you want to use this device for something, know you are going to have a slight delay as you're trying to read information back and forth at that 9600 baud. And we can't speed that up because what happens is if you try to increase that speed between the Arduino and the Bluefruit, then you start ending up missing characters. So unfortunately, that is a fixed value and we can't change that part. So thanks again for making it to the end of the video. And thanks for watching. And if you have any comments or questions or you want to see something explained a little more in detail from an engineering perspective, then go ahead and comment down below and I'll see what I can do. Thanks so much. Have a good one.